Okay, welcome. Today we are going to try to prove angle bisector theorem, which tries to tell us a situation where in triangle ABC there exists an angle AD that divides angle BAC, and at the same time AB equals A, AC equals B, BD equals X, and CD equals Y. And then we're trying to prove that the ratio between A and B equals to the ratio between X and Y. So try to pause the video and prove it yourself. And we'll see how to prove it in a second. Okay, so in order to prove the angle bisector theorem, knowing one thing is very important, which is this. So for any bisector of an angle, for example in this case angle AOB, the distance on any point on OC will have the exact same distance to OA and OB. Why? We can try to prove this. As we all know, like these two are all angle theta, and they have a combined side of triangle. So for example, I'll just assume this is point D and point E, okay? Just for convenience, like the point I selected. So actually in this case, these two are the same and they have a combined sides. And here, we actually have right triangles. So in this case, it is actually angle, side. So triangle OD, let me name this like F. Triangle ODF and triangle OEF is actually congruent to each other. Thus, we can conclude that DF equals to EF. Okay, so after knowing this, we need to keep that in mind. And I'm just going to erase this one and write EF equals DF. Cool? Okay. Now, in this question, we will try to draw some height, because as we all know, like the area of any triangle equals to base times height divided by 2. So we may want to find the height of some triangles in order to because most of the sides are already labeled, so we may want to find the height in order to continue our proof. So for this first diagram, I'm going to draw a height on BC side. Just a second. There we go. And I'm going to name the height, let me put the X a bit the other way. And here you go. I'm going to name this point H because it's height, So the area of triangle ABD equals to base times height divided by 2. So I can express this as X, because BD equals to X, times height, okay? AH divided by 2. Okay, no problem with it, right? So I'm going to do the same thing for ADC. So area of triangle ADC exactly equals to Y, like the base DC, times angle, AH divided by 2. Right? No problem. So in this second diagram, because we see that this is an angle bisector, we may want to do the exact same thing right there. So we will try to put the height from here. Yeah, there we go. Apparently my graph is not that accurate, but it sort of works. So we know that this is equal to that, right? And we can re-express the area of triangle ABD. So it will be area of triangle ABD. That will equals to in this case, like base equals to AB, which is A times, oh, I forgot to name the height, so I will just give it like P and Q. Let me move the B aside a bit. This is B, okay. Times dP over 2, correct? Okay, now we will try to calculate the area of ADC. Triangle ADC will equal to B times DQ over 2. And we can sort of just like mention beside, just use a bracket to make us remember dP equals to dQ according to this theorem. Okay, good. Okay, so now it comes to the last point. So I can express the same thing in two expressions, right? So I may want to do the ratio. Okay, let me just name this real quick. This is expression 1, expression 2, expression 3, expression 4. Okay, so we know that the value of 1 equals to the value of, same triangle, so it's the value of 3. The value of 2 equals to the value of 4, like the value of the equation. So we can do this. We can make the ratio. We can try to find the ratio between two expressions. So it's 1 over 2. That makes sense. Will equal to 3 over 4. So obviously we don't really want to substitute the triangle inside. That's not what we want, but instead we may want to try to find the, like directly put the expression of the area, like not this one, but this expression. So let me just put this aside, and this will be x times AH divided by 2 with the ratio of, let me put a bracket here. So it's actually y of AH divided by 2 equals to, okay, now it's 3, 4. It's A times dP divided by 2 to the ratio of B times dQ over 2. Okay, surprises just happened. AH and AH is exactly the same and they're a ratio, so I can cancel it out. Over 2, we can cancel it out. And 2, it can be cancelled out. And dP actually equals to dQ, so we can cancel it out. So this will be expressed in x over y, I mean the ratio, and x to b. And we can rewrite this in A over b equals to x over y. And there we go, that's the proof for the angle bisector theorem. I hope you enjoyed the video, and if it doesn't bother you, I really recommend you to give a like for this video and subscribe to this channel, and I'll try to update with more problems. Thank you so much. Have a good day.